ओके
सब क्लास थोड़ी
हाँ समेत
सर लेट छूटी थी क्लास
लेट कितना 5 मिनट
जी सर
यस
Okay.
सर 3 मिनट पहले तक चुका हूँ
ठीक है 2-3 मिनट तो खैर हो जाता है बट चलो वी स्टार्ट द क्लास इन 5 minutes let everybody come 5 minutes for those people who have not joined all right All right, so I hope everybody is here. आ गए सब लोग?
Good morning, sir.
Good morning, good afternoon.
Good afternoon, sir.
Gautam, Apurv, Prabjot, are you there?
Yes, sir.
Okay, good. All right, so we continue with our topic, which is quite lengthy topic, magnetic compass. Yesterday, we had seen that how the ship's permanent magnetism may affect the compass, causing deviation. The reason for deviation could be the permanent magnetism, also the induced magnetism. Permanent magnetism is fixed for the ship, but as the heading changes, the effect on the compass is also changing. That we have seen yesterday in that flower diagram. Ship heading north, northeast, east, southeast, अलग-अलग heading पे deviations बदलती है. We had seen a case of a blue pole forward of the compass. That was the ship's magnetism. But you may appreciate that the ship magnetism may have developed in such a way that the blue pole is aft. It will produce another kind of effect, ulta effect. There is a red pole forward, red pole aft. It will have different effect. A blue pole or red pole to the side of the compass, it may have different effect. So ship's permanent magnetism is producing different kind of effects as per their orientation. जो हमने देखा हुआ है कि as the ship is getting built in the shipyard, तो ship का magnetism कैसे भी हो सकता है, ऐसे 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 कहीं पे भी that can be developed. One such case we have discussed yesterday, blue pole forward of the compass. So for understanding sake, this is okay for now. Another thing is that there is induced magnetism. Some structures of the ship, which is soft iron, getting magnetized in one way, heading one way, this is magnetized, sometimes it is not magnetized, sometimes less magnetized, sometimes more, depending on the magnetic lines of forces and the heading of the ship. If the structure that we are talking about is in line with the magnetic lines of forces, maximum magnetization. If it is perpendicular to it, then minimum magnetization, or let us say zero. So the soft magnetism also adds to the deviation. Both of these, permanent and induced magnetism, produce an overall effect. An overall deviation. The basic idea behind a compass is to give me the magnetic north so that I can proceed towards that, apply variation, reduce the deviation to the maximum, whatever is left, apply that and steer the course, which is with respect to true meridian, because the navigation has to be with true meridian. True north से हमें navigate करना है, तो variation deviation जितना भी है उसको apply करना है. Now since it is going to cause deviations, the permanent and induced magnetism, we have to nullify the effect. Nullify the effect of permanent as well as induced magnetism on the compass has to be nullified or reduced to a minimum. So there has to be some kind of corrections to be done to the compass. तो कंपास में तो क्या करेंगे, उसमें तो जो मैग्नेटिक निडल है वो है. Now it is getting deviated because of magnets around it, the ship's magnetism. Would it not be possible कि जो शिप का मैग्नेटिज्म है उसके एक अपोजिट मैग्नेटिज्म हम कंपास के आसपास में और रख दें? एक अगर इधर खींचता है तो दूसरा इधर खींचे तो बीच में आ जाएगा. The permanent magnetism was pulling it this side. If I place something which is pulling it this side, तो जितना इधर उतना इधर तो बीच में आ जाएगा. Is this logic okay? Yes. Nobody talking. Vipin Mishra.
Yes, sir. Yes, sir.
What was my question? अभी मैंने कुछ क्वेश्चन पूछा. What was that? Yes, go ahead.
Yes, sir.
I asked a question. Did you hear my question? No, you are somewhere else. Divya Kumar,
Yes, sir.
did I ask a question?
Yes, sir.
What was that?
सर क्वेश्चन ये था, अगर शिप की मैग्नेटिज्म परमानेंट मैग्नेटिज्म किसी एक डायरेक्शन में है, अगर उसको काउंटर करने के लिए किसी अपोजिट डायरेक्शन में मैग्नेटिज्म रख दें तो ये लॉजिकल है या नहीं?
तो इतना ब्यूटीफुली आपने एक्सप्लेन किया इस चीज को. आई एम वेटिंग फॉर एन आंसर. यू कुड आंसर.
यस सर.
तो इज इट ओके कि सर को इधर धक्का दो तो इधर को जाता है सर, वापस इधर धक्का दो तो बीच में आएगा ना? इक्वल अपोजिट अगर दे दे धक्का तो बीच में आ जाएगा ना?
Yes, sir.
So the idea behind correction is this only. There can be magnetism of the ship, permanent magnetism, which has got three components. Ship permanent magnetism has got three components, P, Q, and R. The P, Q, and R can make the compass move forward or starboard or downwards, upwards. P, Q, R are the three components of the ship magnetism. उसको counter करने के लिए we have three types of permanent magnets, corrector magnets. कंपास के नीचे slots बनी होती है. If this is the compass, let us say this forward, तो forward half में कुछ slots बनी होंगी, holes बने होंगे. कुछ होल्स बने होंगे जो अथवार्डशिप में होगा, और नीचे एक बकेट रखने के लिए, बकेट के लिए एक स्लॉट बनी होती है जिसमें हम वर्टिकल मैग्नेट्स रख सकते हैं. तो पी क्यू आर तीनों का जो भी कंपोनेंट्स है उसको न्यूट्रलाइज करने के लिए वी प्लेस फॉरवर्ड ऑफ परमानेंट करेक्टर मैग्नेट्स, athwardship permanent magnets, and vertical magnets. If I want more, I can insert more magnets. If I want less, I can remove some of them. There are multiple slots available, which we will be seeing in the diagram also. That drawing we will see, which is the most important question from magnetism for second mains. Draw the compass binnacle. Pinnacle is the structure on which the compass is mounted. कंपास बेसिकली इतना ही सा होता है, बट जो पिलर होती है जिसके ऊपर लगता है उसको कंपास पिनाकल बोलते हैं, और उसी पिलर में ये स्लॉट्स बने होते हैं सो दैट कंपास के नीचे में अथवार्डशिप, फॉरवर्ड एंड वर्टिकल मैग्नेट्स रख सकें. So the ship's permanent magnetism is neutralized by permanent character magnets or character permanent magnets. But then there is induced magnetism also, जो कभी होता है कभी नहीं होता है. तो इंड्यूस्ड मैग्नेटिज्म को काउंटर करने के लिए हमें क्या चाहिए? हमें कुछ ऐसा सॉफ्ट आयरन चाहिए जो शिप के स्ट्रक्चर के साथ तो मैग्नेटाइज हो, लेकिन उल्टा हो इस तरीके से कि उसके इफेक्ट को ये नलिफाई करे. जब शिप इस डायरेक्शन में जा रही है, एक चीज मैग्नेटाइज हुआ, तो करेक्टर कुछ सॉफ्ट आयरन ऐसा हो जो वो भी मैग्नेटाइज हो जाए और दूसरे के इफेक्ट को काउंटर करे. दैट मीन्स to counter the induced magnetism of the ship in the soft irons, we need another soft iron here near the compass, which will develop magnetism by the same magnetic field जो उसको कर रहा है. जैसे कल हमने केस लिया था क्रेन के बूम का, तो क्रेन का बूम अगर मैग्नेटाइज हो रहा है सॉफ्ट आयरन, तो हमारे पास यहाँ करेक्टर एक सॉफ्ट आयरन हो जो वो भी मैग्नेटाइज हो जाए उसके साथ साथ, और दोनों का इफेक्ट नलिफाई हो. इज द लॉजिक साउंडिंग ओके? परमानेंट मैग्नेट को परमानेंट मैग्नेट से काउंटर करो, इंड्यूस्ड मैग्नेटिज्म को इंड्यूस्ड मैग्नेटिज्म से काउंटर करो, सो दैट सबका इफेक्ट नील हो जाए. साउंड्स ओके?
सर बट दोनों तो जो मैग्नेटाइज होंगे वो अर्थ के उससे ही होंगे, और दोनों का डायरेक्शन तो फिर सेम ही रहेगा, तो वो काउंटर कैसे करेगा उसको?
ओके, कैसे करेगा? We will see that. Basically, the soft iron that we have, परमानेंट मैग्नेट तो समझ गए, पतली पतली रॉड्स होती हैं मैग्नेट की, उसको डाल देते हैं, नंबर ऑफ देम. परमानेंट मैग्नेट वाले में तो कोई दिक्कत नहीं है आपको?
नहीं सर.
इंड्यूस्ड मैग्नेटिज्म को काउंटर करने के लिए we have something called Flinders bar. There was a captain called Captain Flinder. He only suggested this kind of solution, that we can do something like this. So after his name, this particular rod or bar is called Flinders bar. Flinders bar is a rod of soft iron, vertically placed somewhere around the compass. Of course, there is a lot of discussion. अभी अगर देखे प्रॉपर तरीके से, तो जो कंपास का टोटल अंडरस्टैंडिंग है उसका 35-40% हमने अभी पढ़ा है, 30% पढ़ा है तकरीबन. But that should be okay for you. जब फेज 2 में जाएंगे तो बहुत सारी और चीजें पढ़ेंगे, कॉम्बिनेशंस देखेंगे, कोएफिशिएंट्स देखेंगे, कोएफिशिएंट ए बी सी डी ई, बहुत सारी चीजें होंगी. But at this point of time, it should suffice to know that the soft iron induced magnetism of the ship is countered by another soft iron placed near the compass. One of the soft iron is a vertical rod, जिसका specification भी हम देखेंगे अभी, is a vertical rod placed near the compass vertically. there can be possibility that this can be tilted little bit like this, slew बोलते हैं. तो ये एक तो या तो वर्टिकल हो सकता है कंपास के, या इसको हम थोड़ा सा इधर को भी कर सकते हैं, थोड़ा सा तिरछा कर सकते हैं. That is to add more correction or correction because of different magnets by the same character. So one soft iron correction is happening with the Flinders bar. Other one is by round spheres, soft iron spheres, which is placed in athwarship direction around the compass. अगर कंपास यहाँ है तो हम उसके साइड में, दोनों साइड में ये सॉफ्ट आयरन लगाते हैं. नीचे नट बोल्ट होती है, तो उसको ढीला करके हम इसको नजदीक या दूर भी कर सकते हैं. If I want more effect, I bring it closer to it. If I want less effect of induced magnetism, I can take it away. Similarly, the Flinders bar also, I may be needing small length or more length depending on how much of magnetism correction I want. So the Flinders bar also can be having different lengths, or basically अलग अलग टुकड़े होते हैं जिसमें जितना चाहिए उतना हम इंसर्ट कर देते हैं. जो बची हुई जगह है उसमें वुडन ब्लॉक डाल देते हैं, और जितना हमें सॉफ्ट आयरन चाहिए बार का उतने लेंथ का बार डाल देते हैं. तो उसमें देयर आर सम सॉफ्ट आयरन रॉड्स अवेलेबल ऑन द शिप जो कि करेक्शन के समय यूज करते हैं, एंड देन वी प्लेस इट इनसाइड द Flinders bar jacket. So it should suffice to know for now that soft iron magnetism of the ship is countered by soft iron developed around the compass. These two put together, the Flinders bar and the soft iron spheres, induce magnetism in such a way that it counters the effect of ship's soft iron magnet. Are we good up to this? Prabhjot,
Yes, sir.
Prabhjot, are we good?
Yes, sir.
Okay. So we go to the slide, we take some look at this. मेरे ख्याल से हमने बात किया था कि how the compass card is kept horizontal despite there is Z force which is trying to tilt it, the Z component of the Earth's magnetism, it is trying to tilt it, but फिर भी ये ऐसे रहता है. क्यों रहता है? How we are
सर
making
उसमें
it
वेट्स लगा
horizontal?
देते हैं.
Come again?
वेट्स लगा देते हैं सर दोनों साइड पे, तो ग्रेविटेशनल पुल की वजह से वो अगर एक साइड झुकता है दूसरी साइड वापस खींच देता है.
गुड. बेसिकली उसका रिम जो है वो हेवी कर देते हैं, सेंटर ऑफ ग्रेविटी नीचे कर देते हैं. तो सेंटर ऑफ ग्रेविटी इज ऑलवेज मोर देन द फोर्स ऑफ जेड, जिसके चलते वो ग्रेविटी के चलते हमेशा हॉरिजॉन्टल रहता है. वो कंस्ट्रक्शन भी हमने देखा. So we'll go to the slide, take it forward from where we left in the last class. Let me open the file first and then we share the screen. One second, please. Okay. Second mates. Magnetic. All right, so my screen visible?
Yes, sir.
All right. So this is what we talked about. If there is a blue pole forward, that can be countered by a red pole. So there are forward aft character magnets, which is placed below the compass. Let us see how this is working out. When the ship is heading east or west, the compass will be like this. The blue pole of the ship's magnetism is going to pull it towards this side. That means deviation will be easterly. In this case, if we place the forward aft permanent magnet below the compass like this, with red pole forward, this red pole will try to push it back, right or not?
Yes, sir.
So the blue pole is pulling this side, the red pole here is pushing it this side. So the compass will be in the direction. So similar kind of principle is used in all corrections. जैसे को तैसा और उतना ही बराबर. So this is all discussion on the same thing. Resultant force के बारे में हमने बात किया है. This we have already discussed, that how the deviation changes because of the heading of the ship. So we'll leave that and jump across to conclusions. Let us see. जो हमने पढ़ाई किया था अभी, जो आया था on 8 headings, the cardinal headings and intercardinal headings, north, east, south, west, and northeast, southeast, northwest, southwest, इन सारे courses पे जो देखा था. So this is basically the conclusion of that, which we have discussed yesterday to some extent. So just take a look and re-verify. Main thing to see here is maximum deviation on east-west course, zero deviation on north-south course, easterly deviation on all easterly course, westerly deviation on all westerly course. Then what we are saying, the directive force. Directive force is the force that is keeping the magnetic needle pointing in a certain direction. If we have a needle, compass needle, and the resultant directive force is like this, the compass needle will come and will settle in the direction of directive force, DF. This directive force we have seen is the result of H and the disturbing force P in this case, क्योंकि forward में था blue pole, so that was in forward aft, that was forward aft component. So the resultant is like this. करेक्शन फोर्स फॉर फोर्स पी, ये तो देख लिया हमने. Now, as we said, Flinders bar, you are getting a new word here. Most merchant ships have minus IB. Minus IB is induced B. छोड़ दो, उतना में कहाँ पे आप जाओगे, इसको मत देखो, छोड़ दो. Let us get to this is another case जो कि हम लोग डिस्कस कर चुके कल थोड़ा सा. That was blue pole forward. Now this blue pole is aft. So just study the diagram and look at the writings जो notes दिए हुए हैं side में. Just see if it is appealing. Because you start thinking, then only you can understand. So just think about it, whether it is right or not. If not, please ask me. The last case yesterday that we talked about was the blue pole forward. Here the blue pole is aft. सारी चीजें उल्टी हो गई या नहीं?
यस सर, कल बोर्ड में बताया था सर ये वाला भी.
हाँ बताया तो था. यहाँ पे सारा वेस्टर्ली हो गया, पहले ईस्टर्ली होता था. पोलैरिटी बदल गई है मैग्नेटिज्म की, तो यहाँ पे सारा ईस्टर्ली हो गया. बाकी सिचुएशन वही है. नॉर्थ साउथ पे नील, मैक्सिमम ऑन ईस्ट वेस्ट कोर्सेस, बट द डेविएशंस हैव चेंज्ड इन साइन. जहां ईस्टर्ली था वो वेस्टर्ली हो गए. ईस्टर्ली कोर्स पे वेस्टर्ली एरर, वेस्टर्ली कोर्स पे ईस्टर्ली एरर. The conclusions are similar and understanding is also similar, but again here we see that the headings are changing. Of course it is westerly or easterly, but again it is following the sine curve. Sine 0 पे 0 course पे 0 deviation, 90 पे maximum. पहले ईस्टर्ली था, वेस्टर्ली हो गया. पहले वाला जो कर्व था that was like this. On easterly courses, easterly deviation, westerly courses, westerly deviation. But यहाँ पे इस केस में बात उलट गई. यहाँ पे ईस्टर्ली कोर्सेज में डेविएशन इज वेस्टर्ली एंड वेस्टर्ली कोर्सेज में डेविएशन इज ईस्टर्ली. So we have seen little bit of permanent magnetism, its effect, and we have in general understood how they are corrected. The P, Q, and R of ship permanent magnetism is corrected by permanent corrector magnets, which are placed forward aft, athwartship, or vertical. The ship's induced magnetism, on the other hand, has to be countered by soft iron only, because the soft iron or induced magnetism is not हमेशा present नहीं है. Certain headings पे आता है, certain headings पे नहीं आता है. So we need to have that correction with something which is developing magnetism or not developing magnetism, depending on the course of the ship. So this is what we said. The Flinders bar is a piece of, or rather rod of soft iron, which is normally placed forward of the compass and vertical. There are specifications for this. The general specifications you can see here. The diameter is 3 inches, diameter of the rod. The length is 610 mm, 19 mm, 38 mm, 76 mm, and 152 mm, also 305. These are different sizes which can be placed as per requirement. जितनी मैग्नेटिज्म क्रिएट करनी है, मुझको करेक्शन करना है, उसके हिसाब से अलग अलग साइज लग सकती है. This is placed, as you are seeing in the last line, forward of the ship, and this is able to correct some 3-4 degrees of deviation when the ship is heading east or west. Now we are coming closer to the magnetic compass as real thing. A normal compass, magnetic compass, is nothing but a compass card जिसमें नंबर्स लिखे होते हैं और इसके नीचे में छिपा हुआ there are magnetic rods. The magnetic rods will align with the Earth's magnetism. The red pole towards the north, the south pole towards the blue pole towards the south. Now when the ship is moving in another direction, the compass still reads the same. It is still pointing in this direction, which is to the north, but the ship's reading here is going to be different. When the ship was moving north, along with the ship, the window was reading here, and in the window, heading indicator window, you are reading what? क्या पढ़ रहे होंगे वहां पे? 000 degrees. When the ship is going northeast in the green direction, इस डायरेक्शन में जब शिप जा रहा है तो जहाज के साथ ये विंडो भी मूव करती है, लवर लाइन भी मूव करता है. कार्ड इज रिमेनिंग फिक्स्ड देयर इटसेल्फ इन द सेम डायरेक्शन, बट उसके ऊपर का जो रीडिंग है, दैट लवर लाइन is going to shift and there is going to be a new reading, 040 degree, for example. That means the compass card has to be floated in such a way that it is always free from the ship movement. Ship can go anywhere, the card will remain in the same direction. And for that, what is done? So the card is made like this, with a cap here, with a cone here. and that is suspended onto a pivot. जो numbers लिखे हुए थे वो इसके ऊपर में यहाँ पे लिखे हुए हैं, जो सर्किल होगा कार्ड का उसमें लिखा हुआ है. We are seeing the side view. This cone makes the center of gravity somewhere lower. That is to make it horizontal. It is further enhanced. Gravity is increased. The effect of the gravity is increased more by placing the magnetic needle rods below the compass card. There can be 2, 3, 4. We are seeing the end of the compass needle magnets. Now the whole thing is placed inside a bowl, and this is filled with the liquid. The liquid provides free movement of the compass card. Also, it dampens the movement. Damp करने का मतलब क्या हुआ कि jerky movement नहीं हो, आराम से धीरे धीरे हो, जैसे shock absorber में होता है. So the compass card will move. Yes, surely it will move, but it will move slowly and settle down at a new place. So there is special constitution of the liquid here, and of course the compass card. So we'll take a closer look at the compass card construction. Few details of the compass mentioned here, made up of mica, roughly 15 centimeters in diameter. It is secured to a silver float, nickel silver float, जिसके नीचे मैग्नेटिक नीडल्स होते हैं, जो अभी हमने देखा. The compass needles are naturally iron. Iron will catch rust. So उसको rusting से बचाने के लिए we have that nickel silver thing, casing, which is enclosing this permanent magnets or magnetic needle, so that avoids rusting of the compass needle. We also have seen that there is a cap which is made up of sapphire. Sapphire is basically a gem, stone, hard, but not as expensive as the diamond. Since it is hard, तो wearing tearing कम होती है. Over the use, over the period of use, the chances of that getting, because of friction, वो खराब हो जाए, वो chances कम होते हैं. So sapphire cap is there, and that cap is resting on a pivot, which is iridium pivot, all to ensure long-lasting property of the compass. Longevity बढ़ाता है ये सारी चीजें. तो ऐसे ऐसे मटेरियल यूज किए गए हैं so that it is serving at least for the life of the ship. So this is what we have understood. This one is the side view. This one is the top view, schematic top view basically. So are you able to identify all these things?
Yes, sir.
The pivot is nickel silver that we said. The cap, we said sapphire. The card, we said mica. Diameter, about 15 centimeters, as we said. Magnetic needle hanging below the card, providing more gravitational pull, making the card more stable. So that's the idea. Now take a look at this diagram, which is also the diagram of a compass. So you can see the jewel cap, float chamber जिसके भीतर वो रहता है, और compass ball, what we are saying. There are compass needles here, shown here in the sides. So it can be placed anywhere. It has to be below the card. You have the pivot, you have the jewel cap. What we are saying here is gimbal compass. That means the whole arrangement will be on gimbals. Now you know what is gimbals, correct? पता है ना? गिम्बल क्या होता है पता है कि नहीं?
गिम्बल बॉल्स।
हाँ जी,
Yes, sir. Yes,
जायरो कंपास में देखा था ना?
yes, sir.
Yes, sir.
sir.
तो जायरो कंपास में जो था, जो रिंग का अरेंजमेंट था, वैसा ही रिंग का अरेंजमेंट इसमें भी होता है. The ring arrangement is here also, so that it can float like this. It can remain horizontal. अगर जहाज, मान लीजिए जहाज इधर को होती है ऐसे, तो भी ये ऐसा रहेगा. जहाज इधर को होती है थोड़ी सी, तो भी ये horizontal रहेगा. Why? Because it is mounted on the gimbals. That you have seen already. मेरे ख्याल से जहाज में आप याद कर रहे होंगे कि आप कंपास को पकड़ के हिला सकते हैं, किसी भी डायरेक्शन में, किसी भी तरफ उसको पुश करके धक्का दे सकते हैं. मूवेबल था ना कार्ड, या जायरो रिपीटर का भी होता है बहुत बार. So it is the same arrangement, gimbal arrangement basically. Some more about the compass. The bowl is made up of brass with a viewing glass on top, which is clear, so that you can clearly see the readings. Sorry. Of course, there is lighting arrangement so that you can see the card in the light also. I mean, sorry, in the night. And the brightness of the light can be controlled by a dimmer. So dimmer switch is also there. Since the liquid is there inside this, compass ball में liquid होता है. The liquid will expand or contract depending on the ambient temperature. जो बाहर की temperature है, उससे density change होती है. I think Boyle's law. So the volume depends on the temperature. When the temperature is high, the volume will increase. When the temperature is low, the volume will decrease. तो expansion contraction होता है. उसको absorb करने के लिए we have a diaphragm basically. Diaphragm is basically a sheet in the form of folded kind of sheet, समथिंग लाइक दिस। मान लीजिए एक शीट को आपने पेपर को लिया और उसको ऐसे ऐसे करके मोड़ दिया, तो इसको इधर भी खींच सकते हैं, इधर भी कर सकते हैं। नजदीक करेंगे तो थोड़ा नजदीक नजदीक हो जाएगा, दूर करेंगे तो थोड़ा दूर दूर हो जाएगा। So it can move this way or that way. So this diaphragm allows for the expansion of the liquid. If the liquid is expanding, it will थोड़ा सा दब जाएगा। If the liquid is contracting, density बढ़ रही है और वॉल्यूम कम हो रहा है उसका, तो diaphragm will expand to fill up the gap. Next, there should not be any water going into the compass. The compass as तो वैसे तो ढक के रखते हैं, but it will have to be used when you are using it. Of course, you have to uncover it so that you can see the compass. So it has to be made watertight. तो ग्लास के चारों बगल में रबर का सीलिंग होता है। Then there is a lubber line which is fixed inside the bowl. जो lubber line and heading indicator window जो हमने बात की। So all these are inside the bowl so that with the ship, the bowl moves, but the card remains floating and always pointing towards the north. So this is compass binnacle, not compass binnacle, but the upper part of the compass. Same thing जो अभी हमने देखा था वही है, but little bit more elaborate. This also indicates the gimbals on the side so that it can move at least in two directions. Take a screenshot. Next. This we have already talked, so you just go through it, read yourself. अगर कुछ डाउट है तो बताइएगा मुझको. We have discussed it multiple times. This may be a question coming in the exam. How the arrangement is made to keep the card horizontal at all times. Next. समझ में आ रही है बात या नहीं? We have discussed
आ
it.
रहे हैं सर.
Okay,
Yes
good.
sir.
When you are coming to the last, explain to me what is point of suspension.
सर जिस पॉइंट पे अपना कार्ड स्टेबल है
बेसिकली द कैप एंड द पिवट वहीं पे सस्पेंड है ना, वहीं पे लटका हुआ है।
यस सर
तो बस ये कैप और ज्वेल कैप जो हमने बात की थी और पिवट बात किया था, ये वही है। सेंटर ऑफ ग्रेविटी उससे नीचे होती है, दैट वी हैव ऑलरेडी सीन। नेक्स्ट,
चेंज नहीं हुआ है सर।
चेंज नहीं हुआ। अब
हाँ सर अभी आ गया।
ओके,
यस सर नेक्स्ट।
next is the composition of the liquid. We said liquid filled compass bowl or compass.
सर स्लाइड
So the
चेंज नहीं हुआ
liquid is a
सर पहले
mixture
भी
of
यही
these.
स्लाइड थी।
सर पहले भी यही स्लाइड थी सर।
अरे तो ये वाला स्लाइड नहीं आया था, रुको।
नहीं सर ये
ऐसा
वाला
अभी आया
नहीं
सर।
आया।
अभी क्या देख
अभी
रहे
आया
हो?
सर एक मिनट।
What are you seeing right
सर वो
now? Point
कंपास
of
कार्ड
suspension वाली।
अभी तो पॉइंट ऑफ सस्पेंशन है सर।
Okay, next.
अभी तो
Are you
नहीं है।
seeing a diagram?
सर चेंज नहीं हुआ सर।
Wait a second. Are you seeing the diagram now?
नो सर।
नहीं सर पॉइंट ऑफ सस्पेंशन वाली स्लाइड है।
अरे तेरा क्या हो रहा है ये? रुको।
हाँ सर अभी आया डायग्राम।
ओके, तो सेंटर ऑफ ग्रेविटी की जो बात कर रहे थे, तो आपको ये सिंपल डायग्राम बताना है अगर ये क्वेश्चन आती है, हाउ इट इज मेड टू बी रिमेनिंग हॉरिजॉन्टल ऑल द टाइम। तो एक्सप्लेन करना है राइटिंग में, एंड देन डायग्राम में बी मेड लाइक दिस। The Z is acting here downwards, trying to pull it, but the gravity here pulls it this way and keeps it horizontal all the time. ग्रेविटी का फोर्स हमेशा ज्यादा होता है Z से, इसलिए ग्रेविटी हमेशा जीतती रहती है और हॉरिजॉन्टल रहता है। Next, composition of the liquid. The ship goes from place to place, कभी frozen area में, कभी warm area में. So the liquid has to be such that it is not freezing. नहीं तो freeze करेगा तो कार्ड जो है जम जाएगा अपनी जगह पे। So there are certain properties of the liquid which is required, and that is achieved by mixing distilled water with pure ethyl alcohol. The mixture of these two liquids makes the freezing point quite low, -30 degrees centigrade, does not expand and contract very much, so coefficient of expansion is less. ज्यादा वॉल्यूम चेंज नहीं होता उसका। The distilled water having no impurities inside and ethyl alcohol put together, they do not discolor the card. The card remains as bright as it was new for long period of time. The density of the liquid is less. The relative density is less, 0.93. That means it is not restricting the card too much, but it also provides damping. Restrict करता भी है, but बहुत ज्यादा नहीं करता। तो कंपास कार्ड इधर से उधर नाच रहा हो ऐसा वो नहीं होता, because it will come slowly this side and this side. The movements are damped by the liquid only. आप हवा में हाथ ऐसे एक तरफ से दूसरे तरफ हाथ घुमाइए, एयर का डेंसिटी कम है, हाथ जल्दी से पार हो जाता है. बट द सेम हैंड इफ यू पास थ्रू वाटर, व्हाट हैपेंस? हाउ इज योर हैंड मूविंग?
सर थोड़ा स्लो मूव होएगा.
स्लो हो जाता है. Why? Because the water density is opposing your movement, and so your hands are becoming little slow. That is the whole idea behind damping. So when we place the liquid in that the card is moving, the card moves slow. Next. As we have already seen that there is a diaphragm expansion absorb करने के लिए, तो उसके नीचे chamber होता है बना हुआ, expansion chamber. That takes little bit of expansion, absorbs the expansion of the liquid. जब liquid expand करती है तो वो diaphragm दब जाता है नीचे, and the card remains, the card remains submerged in the water all the way full. So the expansion chamber is basically empty space. उसके ऊपर में diaphragm लगा हुआ है जो दबता है, थोड़ा ऊपर नीचे हो सकता है. So this was the construction of card, compass, the composition of the liquid. There are some review questions. See if you are okay with it. Important parts of the liquid card compass. Can we name some? The compass ball, the card, the pivot, the jewel cap, gimbal rings, expansion chamber, diaphragm, lower line. Can we?
Yes sir.
Second question is all done. मेरे ख्याल से composition of liquid we attended just now. Looks like we are going to take one more class to complete this, but it is almost over. एक कंपास कार्ड का हमें डायग्राम बनाना है. कंपास कार्ड का कंपास बिनाके का, which is most important question. 7 out of 10 times the question which is asked for second mates is draw the compass binacle, name the parts. तो अभी तो हमने सिर्फ कार्ड देखा था या कंपास देखा था, बट होल बिनाकल में वो स्लॉट्स भी होंगी परमानेंट मैग्नेट के लिए, वो फ्लिंडर बार भी दिखाना होगा, वो सॉफ्ट आयरन भी दिखाना होगा, स्पेयर्स दिखाना होगा which is placed athwart ship. There will be bucket also for keeping the vertical magnet. तो सारी चीजें होंगी, that we will be seeing in the next class. Any questions?
Thank you, sir.
नहीं सर.
चलो, thank you बोल दिया. Then
Thank
I
you,
say
sir.
thank you to you. चलो, bye bye. Thank you.
Thank you, sir.
चलो, bye bye. Signing off. Take care.